Hi, I'm Jacob.
Hi, I'm Vivian.
And I'm Patrick. And this is what we're going to use to do science. The spark. pH is the measure of a substance's acidity, with substances whose pH values exceed 7 are considered basic, while those whose pH values are under 7 are considered acidic. pH can be calculated by calculating the negative logarithm of a substance's hydrogen concentration, or can be directly measured with a pH sensor. To measure pH on a spark, you must use the pH probe, which is plugged in here. Now, make sure the plug is plugged in before you go on any further. Now that our pH probe is plugged in, click the build option on your spark. Now, since we're taking pH of a substance, we want to click the pH option for our graph. And since we want to use a line graph just because we want to use one in this situation, we will click the line graph option.
If you want to view multiple graphs, simply click on the desired measurement and display type. It will then appear here.
Now click OK to go on. Now first, before you take the pH of anything, you will want to calibrate your pH sensor. Go to the icon in the bottom right corner of your spark. Now click Calibrate Sensor. Now, when it says measurement, you will want to make sure that you are measuring pH and not temperature, because we're measuring pH in this situation and not temperature. Now that we have pH selected, we go to Next. Now that we're at the calibration menu, you want to calibrate the pH of your substance first, or calculate the pH probe first, by using a substance with a pH of 4 and a substance with a pH of 10. Now you want to go to standard value, click OK, make sure that we have 4, and then put your spark probe in the substance with the pH 4 and click Read from Sensor. It's all good now. Now we need to rinse it in distilled water.
So in the top right corner, we have all our runs listed here. If we click on this box, we can see that we have quite a few. If we want to view one specifically, we just uncheck the ones that we don't want to see, and it'll show us one. If we want to view more, we can just check all the ones that we want to see. Now we don't want to look at all these because it gets cluttered. Now let's say that you want to do something specific with your runs. You're going to click on the Tools, bottom right, Manage Data, and then Manage Runs. And it gives you a few options here. You can delete the last one. I can do it! Delete the last run, delete all your runs, or delete a specific run. We don't want to delete any right now, so we'll just say done. And OK. OK. So let's say you want to change the measurement or the unit that you're using in a graph. First, we're going to click this graph button on the bottom left, and then these 3 bullet points here on the bottom right. So we just measured barometric pressure in kilopascals, but a unit that we use more often is atmospheres. So let's just click kilopascals, then click atmospheres, and then click OK. And as you can see here on the y-axis, it's labeled barometric pressure in atmospheres, while before it was kilopascals, and on the x-axis is still time.
In order to find the exact information at one point, you will need to find the exact x and y coordinate of that point. To do this, click the button that looks like a cursor. Then, click on any point in the graph for which you want to know the exact information. It then gives you your x value and your y value. Your x value will be the time, which in this case is measured in seconds. So at 23.00 seconds, we have this x value. At our y value, we have 100.38. Since we're measuring our barometric pressure in kilopascals, It means that at this point, we have a barometric pressure of 100.38 kilopascals. We are at 23 seconds and 100.38 kilopascals. Let's say you have this set of data, but let's also say that it's a bit difficult to read either because of the way it's scaled or the way the information is placed. Such as if the graph looks like this. Now, what you will want to do to find the fit of data that makes the most sense to your specific set of data is to click this graph button, then click this button with the circle, or with the square and arrows around it. That is the best fit button, and as you can see, it has fit the graph to the way that where the data is easiest to read.
So let's say we want an expression that'll give us a line that will express the entire graph. This is called linear fit. So in order to do that, we're going to click the graph tool on the bottom left, and then click this button in the first column, and then click linear fit. Now, okay. And so this box here gives us an expression for our line. M is the slope, so you can use that as the slope of your line. And B is the y-intercept. So if we want to get the slope at an exact point, first we click the graph tool, and then we need to select the point that we want. So let's choose right there. Let's say I want a little bit more to the left, so I'll go a couple more to the left. Then unselect the pointer, and you'll notice that the point is still selected, and then you'll click this button on the bottom right, and it gives us all of our data for that point. The slope, the x point, and the y point.
So one thing that you're going to need to do on some labs is to calculate the minimum and the maximum of our graph. So in order to do that, you're going to make sure you have the correct run selected that you want to do. So if we wanted to do run 2, we'll click on run 2. And then you'll go to this graph tool on the bottom left, and then click this sigma button. And it'll give us a couple options, so we can do minimum, maximum, mean, standard deviation, count, and area. If we want to do minimum, just click on minimum, and then click OK. And it tells us right here that for run number 2, the minimum is 99.46. After you finish collecting your data, you will want to save it so you can open it up or look at it later. In order to save a specific screen, like say this one, click the camera button in the top. Then you'll click the button that looks like a pencil and a piece of paper, and this will save it to your lab pages. You may then go to the button that looks like a triangle with circles, then go to Journal, and if you have a Spark with a USB drive in it, you'll be able to export your data into the USB file. Now, if you want to save this data as a Spark View file, you will then go to the triangle again, and on lab pages you will click Save File As, then you'll give it any name. So Save File As, give the file a name, and then you will want to click Export Data if you have a USB inside. Oftentimes it'll be a better idea to save the file as a Spark View instead of as separate screenshots, because if you save it as a Spark View file, as a .spk, you'll then be able to open the file up and then use it with most of the capabilities that a Spark has, except on any home PC or laptop that also has Spark View software enabled.
Patrick, hard at work.
Oh no, my mom doesn't make good potatoes.
Ooh, I got that on camera.
Mom, I love you. And then we're going to click this box that looks like a sigma. Now just...
And you clicked the wrong thing.
Hydrogen ion concentration, or can directly be measured with a pH sensor.
Go there! You missed the shot. Oh, bring it. Okay. No. Take it out.
We're also going to
And bring it in.
error between the calculated.
Not that close.
Not that close.